Hello, everyone. Great to see you here, and thank you for joining. This is actually our last formal WiseAct webinar, and we're very privileged to have another distinguished speaker today with us. So we have Dr. Alexandros Nikitas, who's a reader in smart transport at the University of Huddersfield Business School. Also the Huddersfield Future Mobility Lab founding director. So that's a relatively new initiative that has started in Huddersfield and through the various activities Alex has been doing. He's also the deputy director of the school's Behavioral Research Center and also the upcoming chair of the university's Transport Study Group Executive Committee. So I guess quite a few of you know the UTSG. It's a very large organization in the UK, but has also international audience with more than 60 universities on board. In addition to that, Alex is also the associate editor for the Journal of Transport and Health, and also a member of the editorial boards of the journal Research in Transportation Business Management, which we have also Professor Maria Tarts, that's another privilege for us, and case studies on transport policy. So quite a few activity on the journal front also. And in general, Alex has been very well published, more than 90 journal and conference papers, focusing usually around sustainability, social inclusive mobility, but also, and this is the topic of today, automated, connected, alternatively fueled and shared transport, and quite a few other issues which I'm sure like Alex will touch upon today. So on that note, Alex, I'd like to welcome you and leave the floor to you.
Many thanks, Nicholas, for the invitation and the very nice intro. Actually, what I'm going to present today, dear audience, is the work that we've done together with Nicholas Thomopoulos and Dimitris Milakis. So this work is about automated transport and the environmental and resource dimension of it. And what we try to do is try to actually propose a way to enable vehicle automation to somewhat support sustainable urban mobility. So what is the core of today's presentation is the introduction of the nexus. So as I said, this is based on a very interesting article that it was published last year from after a special invitation from the annual review of environment and resources, co-written by Nicholas Thomopoulos and Dimitris Milakis. Dimitris Milakis, for those that don't know him, he works in the Institute of Transport Research for the German Aerospace Center. And I'm just providing, for those that will have access to the slide, the citation of the particular paper, more or less gives you a more kind of a precise perspective of what we're going to discuss today. It was a great honor to be invited to submit in this journal. They accept papers only after a special invitation. So it means that us three probably are doing something quite interesting in this particular domain, the autonomous connected transport domain. A little icebreaker. It was very interesting what I saw the other day. It was Elon Musk, whoever don't know him, he's like the founder of Tesla, which is a pioneer when it comes to electrical vehicles and also automated vehicles. He just make this kind of very bold statement, and if he does, this is the guy that actually makes this type of statements, then there is some pessimism about the potential role of autonomous vehicles and how this will impact the environment. What he said is that self-driving car will amplify traffic to insane levels as you won't feel the pain of driving yourself. So this kind of declaration makes this type of presentations even more important. But very interesting thing that I will need to highlight is the wording he chose. So he is talking about cars, so more or less kind of shrinks the level of the impact of the transition to a automobile-oriented mobility. And we will see that this is actually part of the problem that exists, and this is the source of worst-case scenarios. But if we actually try to think outside the box and think beyond automobility, we might have some answers. So the contents of today's presentation, we just had an icebreaker. I'm going to go through the background and provide a research justification, discussing about the research gap we try to fill in. I'm going to set out the exact research objectives of the work, discuss a little bit about the way that we did this literature review, and then we're going to talk about the main topics, the most important one, critical one, and bigger one. It has by far the most extensive coverage in the literature is road transport. And then we're going to talk briefly about rail transport, air transport, and water transport, and the potential footprint in terms of environmental harm or change that they could be making. And then after we go through all that, we will try to theorize a little bit. I'll introduce you to our nexus, and then we'll close this presentation with some key conclusions and some future directions, some ideas, some fruitful areas for further research. So let's start by saying the obvious, that vehicle automation, transport automation, autonomous transport, autonomous urban mobility is a fascinating new technology that we haven't yet mastered. I mean, technology-wise, we're quite close, but legally, regulatory-wise, we're not just there. The people are not ready to kind of embrace this technology as yet. And therefore, this is going to be a destructive kind of intervention, a disruptive. It will create disruption in the way we provide transport for over 100 years now. Vehicle automation could lead, if managed responsibly and planned thoroughly, could lead to several improved situations when it comes to accident prevention and traffic safety, when it comes to social inclusion, when it comes to riding experience. It will actually potentially motivate better sharing, new type of business models that are not fixated around car ownership. It's going to have potentially a good effect on road traffic congestion. We're going to bring some reductions. And then, more importantly, for this particular topic that we're discussing, do not forget we are talking about the environment and resource implications of automated urban mobility. It's about air pollution problems, can help our response, can minimize traffic emissions in the best case scenario, promote environmental sustainability, and reduce energy consumption. At the same time, though, this disruptive technology have the potential to actually do some wrongs. It could increase the vulnerability to hacking, software and hardware flaws. It could create big brother effects. It could easily facilitate travel data exploitation. They're going to be legal and ethical and regulatory challenges that we might be facing of moral dimensions. We possibly, especially during the transition phase and particularly during mixed traffic situations where the autonomous vehicle will share the environment with semi-autonomous or human-driven vehicles, we might have elevated traffic accident and congestion rates. We're going to have behavior adoption, situational awareness, and user-resistant problems. We're going to see a huge effect when it comes to employability, and this will lead to a potential skill reform because we won't have drivers and driving-related occupations. They will not be needed anymore. But when it comes to environment, when it comes to energy, when it comes to resources, what we might see if vehicle automation is not managed responsibly is that we're going to see a rise in emission and resource overconsumption. So this transition to an automated urban mobility paradigm is a complicated one. It's one, the current conventional transport system is responsible for about 15% of globally to climate change gases. So we already have a serious trouble when it comes to the production of pollution. The transition is a difficult one, and we have to check it methodologically. We have to understand it thoroughly and try to assess the sustainability-centric dimensions of the different modes of transportation. We're going to concentrate on passenger transportation, and we're going to look at multimodality. And this is a unique feature of this particular paper, because we're actually going to look not only to road, but also to rail, air, and water mobility alternatives. Some of them are a little bit futuristic, but it's better to be proactive when we are trying to lead and manage a potential transition. We specifically refer to high and full automation levels, and our scope is not about logistics, and it's not about long distance travel. These require different set out for problematization and theorization that we're not going to cover, and we kind of recognize this. The research objective of this particular paper is about the environmental and energy related opportunities and challenges that underpin the full-scale launch of automated urban passenger transport. We're going to discuss a little bit about the factors affecting environmental and resource consumption performance on automated mobility, and I'm going to introduce a nexus that celebrates vehicle automation, connectivity, electrification, and sharing, but also adds another element, the important element of multimodality. And potentially, if this is the ideal scenario, then we actually might be able to manage the transition in sustainability terms and make it more fair for the society. So the methodology that we used was a thematically organized narrative review. For consistency and quality reasons, we actually used some of the keyword search criteria and standards and principles of a systematic literature review, meaning that all three of the authors had a very close look to the literature and actually combine their independent takes. Our review focused primarily on Scopus listed journals that were written in the English language, and this is the difference why this is not a systematic literature review. We actually tried to identify gray literature in areas where no peer-reviewed articles were available. About 98% of the papers that we examined, that we evaluated, assessed, and included in this particular work were published during the last decade. Some of our keyword searches overlapped. For example, we actually used terms like city and urban, and we've seen a little bit of variation, but some of the papers were the same. Same thing with the word automated and autonomous. So we excluded similarities, and we actually concentrated on the specific type of articles. We actually seen more than 1,050 titles. We reviewed 400 abstracts very systematically. And at the end of the day, we included 132 outputs in our final work. Our criteria were subject-specific relevancy, the recency of the research output, the impact factor of the journal that hosted the article, and for some older articles, potentially we've seen the number of citations as a proxy of quality for some older references. And this is the little map that we created, the Scopus keyword searches, and you see really what was the situation on May 2021 when it comes to papers in that particular area. And it's amazing. This gives you the first proof, the first evidence for that, how fixated the literature is when it comes to automobiles, car equivalents. We had very, very little papers ever published when it comes to rail, air, and water transport. So, to confirm that, I can tell you that 90% of the literature and even more was on automated mobility, and when it concentrated on connected and autonomous vehicles as car equivalent replacements. So mostly the literature uses cars as something that is synonymous to a car equivalent, which is not necessarily the case. This is at least what we say in this particular paper. So cars could impact car ownership, road traffic congestion, vehicle miles traveled, pollutant emissions, energy consumption, and the repercussions for climate change mitigation are highly uncertain due to some very different competing mechanisms that their magnitudes are very, very difficult to estimate and evaluate. So in theory, CAVs could facilitate the precedented levels of eco-efficiency and function optimization. And these are potentially very, very good in environmental terms, especially when cars where connected and autonomous vehicles are programmed to operate aggressively, then we have significant kind of savings when it comes to energy consumption and air pollution. However, depending on consumer choices, the shared or private provision of car services, the adoption of non-adoption of electric and hybrid technologies to operate these vehicles, and whether these vehicles, how these vehicles are programmed, we could actually potentially create more energy consumption and environmental harm. So it's very, very easy to go from the right direction to the wrong direction. CAVs are projected to impact the total greenhouse gas emissions through their potential to reduce vehicle ownership if, for example, shared autonomous vehicles are the prevalent choice for the markets, increase vehicle use intensity, like Elon Musk said, extend urban's role. This is very, very big, because if people do not have to drive daily, they can live further away from their employment or from the places that they need to be every morning, and this could create more vehicle miles traveled. Could change the vehicle fuel consumption rate, and we're going to talk about the different synergies when it comes to fuel consumption with autonomy. Popularized ride sharing, which is very, very, very important. And then these vehicles will be able to eco-drive, and this means optimized braking, acceleration, deceleration, and shift gears automatically. So one of the key issues that we're gonna potentially see is the dominance of shared autonomous vehicles. And this is a likely scenario and a potentially positive scenario, because this will potentially replace some of the number of cars needed for self-owned personal vehicle travel. So at the same time, combining ride sharing with AVs could amplify both of them, could help both of them to expand. So in very favorable future scenarios, SAVs could actually lessen greenhouse gas emissions by reducing traffic congestion, by facilitating the diffusion of alternative fuel vehicles, and we're going to see how important that is in the next slide. They could also help matching vehicle size to trip requirements and then produce some economy in the fuel consumption, and reduce parking needs, because they're going to be always in the move and you're going to have fewer vehicles in the system. Nearly 60% of the single person trips could be shared with others with 5 minutes of additional travel time. Then another very, very important consideration is to consider the autonomous electrical vehicle. These are vehicles that do not produce greenhouse gas emissions during their operation, at least. So it's very, very important to actually link the production of electricity with renewable energy sources. It's very, very important. Otherwise, these vehicles could be pollutant as well. And in every term, when it comes to sustainability, they are better than internal combustion engine autonomous vehicles. Automation can be an accelerator of electrification, and at the same time, electrification may have the largest positive impact when it comes to CO2 emissions per kilometer driven. So the potential power of an autonomous vehicle amplifies significantly if it's electrical. So in case where we actually use simple AVs in simulations, we might have increased pollutants like CO2 and NOx. When we are using electrical autonomous vehicles, we actually might have a significant reduction of up to 30% of these air pollutions. One problem with autonomous electrical vehicles is the lithium-ion battery life cycle, would be particularly problematic in environmental terms. And we need to seek ways to find how we can make recycling a little bit better in that case. Then we can bring the sharing approach in the mix as well. So we might have shared autonomous electrical vehicles. These will be vehicles that will be able to actually manage the range and charging activities and overcome the problems that today's conventional EVs have with range anxiety and charging issues based on real-time trip demand and established charging station locations. Shared autonomous electrical vehicles could be able to reduce greenhouse gas emissions even by 73% and energy consumption by 58% when compared to an automated fleet of internal combustion engine vehicles. So at the same time, SAEVs may add significant storage to the grid in a time which is crucial when we have a rise in the renewable energy penetration. So SAEVs can reduce cumulative energy and greenhouse gas emissions primarily because of their electrification, but actually can produce further reductions through accelerated electrical grid decarbonization, dynamic ride sharing, longer vehicle lifetime, more energy efficient computer systems, and faster fuel efficiency improvements. Leaving the world of automobiles now to enter the realm of public transport. So a very important element for automated road transport is the prevalence of autonomous buses. We have very little research on autonomous buses and their particular environmental footprint per se. The autonomous electrical bus, again, is the potentially strongest facilitator of environmental benefits because they actually reduce environmental pollution, heat generation, and noise pollution, and combine electric power and multi-seat service together with autonomy. A very important thing is the potential inclusion in the new transport systems of tomorrow of automated shuttles or port or minibuses that could move 8 to 10 people. They are a much better replacement of cars for first and last mile neighborhood feeders in bigger type of buses. Automated rail transport is the next topic that we're going to cover. Rail industry was the very first that tested and introduced automated transport in some of our key metropolis around the world. We have examples here in the UK, in London, DRL, that have been successful automated services for quite a few years. This is because these systems are segregated from mixed traffic situations, and this reduces traffic accidents quite considerably. There are 5 grades of automation when it comes to rail services. We start from 0, where we have manual operation with no automatic train protection. Then we have manual operation with automatic train protection, semi-automatic train operation. Level 3 is driverless train operation, and level 4 is unattended train operation. Despite the progress that has been made, we haven't fully realized the potential of automated rail transport. We only see this in big metropolis that they have a lot of money to invest. So we are very far removed from no train driver or attendant scenario for the time being. Automated transport has not led until now to any significant environmental benefit other than eco-driving, which is important in its own merit. However, the big kind of problem that we might face is that if automated mobility is primarily car-centric, we're going to see reductions and modal shift from the rail-based services. And this potentially could have a very negative effect to the environment, to energy consumption, and resource management. Mobility as a service could be a key if they try to enhance rail services in these multimodal planner agendas, and might have positive influence for the city level scenario. Then we should be talking about automated air transport that potentially have the biggest impact in the city level, because we are talking about a completely new form of transportation, completely new travel mode alternative that could actually conquer our skylines and create air traffic congestion for the first time. There's significant problems to solve, like the allocation of launching, landing, parking space, the establishments of no-fly zones and fly corridors, the introduction of search, alarm, and rescue operation systems, the interaction with other modes of transportation, and the synergies with ground and water AV systems. And potentially, PAVs could create a totally new set of opportunities and problems. Okay, there are already experiments happening about the use of personal area vehicles, flying cars, as people might call them. It's very, very important to base this technology on electric powered or hybrid type of technologies. It is very, very important to have any type of greenhouse gas emission reductions to actually use these modes very, very strictly at the ride sharing schemes. And these schemes should be replacing non-shared public transport surface travel. In any other situation, this is extra traffic that could be harmful for the environment and produce extra energy consumption. One way to actually affect air transport, automated and transport, is to reshape the vehicle design. So we might actually go to different type of technologies that are drone-like, and we call them vertical takeoff and landing aircrafts, VTOLs, and this could be the flying norm in the near future. And because they will be able to fly from much smaller parking spaces, the vertiports. If we use VTOLs, we can reduce greenhouse gas emissions quite significantly when compared to internal combustion engine-based personal area vehicles, and even when compared with battery electric engine-based personal area vehicles. If we manage to actually concentrate on ride-sharing provision only, then we might have significant kind of greenhouse gas emissions and CO2 emissions. And if we obviously manage to actually combine this with electromobility, then we might have a winner. Automated water transport is a huge industry with lots of investments, and potentially automation can help the cost and environmental impact of this type of marine activities. We have some type of process when it comes to the creation of electric autonomous vessels, but still we are in the very infancy of this type of interventions. Minimizing times in rescue missions, in response times, could actually help reduce travel time and respectively reduce emissions. We have very strict regulations for many, many countries when it comes to pollution in water transport. So we feel that transport automation may have a positive impact when it comes to actually saving energy. These vehicles will eco-drive. However, we are not very certain about the time frame of this transition, and we've seen not even a single study that was significantly concentrating on the way highly automated water transport could affect the marine wildlife ecosystems and the environment of a city as a whole. Let's go to now to actually try to sum everything up, identify gaps, questions that need answering in the future. There is still an alarming scarcity of research when it comes to the environment and energy related aspects of non-CAV multimodal application of vehicle automation. So all the research that we actually found were simulations about car equivalents, automobile alternatives. So we really need to see beyond that, to leave this realm and look a lot more into the multimodality and avoid the monoculture of road transport that is car-centric. So we need extra studies on that. We need to look a lot on the experiments that are happening across Europe with autonomous buses. We need to actually evaluate a lot more thoroughly the already existing and operating for many decades autonomous light rail and metro systems that exist now only in a few metropolises across the world. We need to have research that is more about environmental policy and social applied science. Most of the research that we actually identified is very, very technical, and we need to go beyond that. For example, there are thousands of papers about how we can actually create a system that can actually fly when it comes to air urban mobility, but we have almost zero kind of inputs about the potential environmental and resource-oriented impacts of such an intervention. And there is very, very little trying to combine the different perspectives that we have already discussed, the perspective of our nexus. Vehicle automation needs to be connected. It needs to be linked very well with connectivity functions, with sharing, with electrification and multimodality. And this is the very kind of result of our study. We brought this a very interesting framework in place when we were inspired by the 3 pillars of sustainability. And this is the 4 complementary empowering counterparts of automation: connectivity that allows AVs to communicate and cooperate. And this is very, very important. Without connectivity in place, automation doesn't really work when it comes to sustainable benefits. Then we need to think about alternative fuels and mostly about electrification, and kind of leave behind the oil-oriented perspective of fuel dependency that we faced for many, many years. Obviously, electromobility should be linked with renewable energy source production of electricity. Sharing is very, very important, and it's not just shared autonomous vehicles. We need to actually start thinking and rethinking the way public transport could embrace automation. If that is not the case, then we have serious problems when it comes to sustainable urban futures. And then multimodality. This is what we thought, and what is very, very important. This has not been discussed that much before, or almost we haven't seen it in any paper that tried to bring together the different modes of passenger transport automation. We think that multimodality could be a hugely impactful element in the way vehicle automation unwraps in the future. It's very, very important to leave behind the monoculture of road transport and car-centric services, and we actually need to emphasize the mass transit side and potential of mobility. It's very, very important to think about parameters like education. Very, very important to educate people, to inform people about the changes, because informed people are better decision makers. It's about very, very important to think about the business and market perspective of these things. They're going to be new business models. How can we push for shared systems, ride sharing, and public transport shared systems as well? We have to kind of disincentivize car-centric services. Technology is very, very important. It's a key piece. We're doing very well when it comes to technology, but policy, legislation, and regulation is still a problem. So what we say is, if you look at this particular figure, that we're going to have a supporting system to our aspirations for more sustainable and livable urban futures if we actually get to the ideal scenario of automation where this coexists and is inseparable from electrification, sharing, connectivity, and multimodality. Only in the very middle of this schema, you can have a positive impact for the environment. And we have to say that despite that important kind of discussion that we bring, and our kind of achievement is that we gave a new highlight for the important role of connectivity, but also we introduced multimodality in the very celebrated triptych of automation, sharing, and electromobility. We actually need to understand that we have right now more questions than answers. We haven't decoded, demystified the situation at all. We just help generating new problems, new research gaps, new research questions that need an answer. We actually admit and acknowledge that this ideal nexus could have a small impact in the way transport impacts the environment, and it's not a panacea on its own. Actually, it has to be complemented by active transport prioritization interventions, virtual commute and teleworking initiatives, and travel demand mechanisms. Without them, we might have a very, very bad future when it comes to sustainability, if all we concentrate is automation. So some directions for the future is the need to conduct more experimental studies for the vehicle and the network system levels as well. We need to understand the wider impact of automation deployment and do primary data collection and analysis with users and potentially non-users. And we have to demystify where we need to invest in infrastructure and communication technologies. We have to understand the relationship between connected and autonomous vehicle transport, the physical and cultural shape of the smart city, the emerging shared mobility economy, the user willingness and market readiness to embrace electrification, and the embracement of multimodality. We haven't defined yet all this. This is the first time that we set out to deal with this kind of nexus. Shared autonomous electrical vehicles may have a very, very significant impact when it comes to energy demand, because they can actually help us diversify our energy management policies and practices, and at the same time could help energy storage. Legislation, travel demand measures, good planning, trials, living labs, awareness campaigns, training schemes with a specific and exclusive pro-environmental emphasis can be very, very important tools that will support this nexus. And mass could potentially be an important priority, especially if it's built around public and mass transit services and incentivize car-centric services. Final minute, let me say something about our new initiative. This is a very nice kind of opportunity to say a few words. We just initiated a few months ago the Future Mobility Lab here in Huddersfield Business School in the University of Huddersfield. They did an internal investment, the Vice Chancellor and his team, on us, and invest in our research excellence in transport and logistics studies. We're looking at sustainable and social inclusive mobility. We're looking at this type of nexus-oriented transport and ways to actually change travel behavior and inspire positive change. We try to create a forum for helping out academia and practice to decarbonize transport. And we have a very interdisciplinary perspective, including business, behavioral design, planning, engineering, and computing approaches. Many thanks for listening. Any questions?
Thank you. Thank you very much, Alex. I think it's really great, actually, this overview. And it's been some time, actually, since we started with similar activities in WISAC. So it was about 5 years now since the University of Zilina hosted us in Slovakia, but it was across the same kind of nexus that you focused on. So this is really great, actually, to see that things are going on, and congratulations also on the new initiative on Huddersfield. So I'll just say thank you to then open the floor again for some questions and discussion afterwards. So thanks again, everyone.